Temperature is one of the factors that influence the chemical equilibrium. So when you change a temperature, iba khona a reaction that you favor. For example, you can favor number one, the exothermic reaction, thermic reaction. Then number two, when you change temperature, maybe you will favor endothermic reaction. So you favor endothermic reaction. Okay, so exothermic reaction uzoba favored xa usenzani kwi-temperature. Once you decrease the temperature, decrease in temperature, decrease in what? In temperature. Once you decrease the temperature, exothermic reaction is favored. Once you decrease, exothermic reaction is favored generally. Once you increase temperature here, increase in temperature, in what? In temperature, you favor endothermic reaction. Endothermic reaction is favored when you increase temperature. Then kwi-reaction yethu ngusiyajonga ke ngoku uba forward reaction, is it exothermic? So if forward reaction is exothermic, once you decrease temperature, forward reaction is favored because forward reaction is endothermic. Once you increase temperature, endothermic reaction is favored. If forward reaction is endothermic, increase in temperature will favor forward reaction. So makesenze umzekelo. Let's say we have the ammonia. That is formed by hydrogen gas. That reacts with, let's say it reacts with a nitrogen gas. Then we have what? The product, which is ammonia. That is the ammonia. Two molecules of ammonia, which is also the gas. Let's say delta H, and this reaction is less than 0. So since delta H is less than 0, when delta H is less than 0, that is exothermic. Delta H is less than 0, that is exothermic. When delta H is greater than 0, that is endothermic reaction. So in this case, delta H is less than 0, therefore forward reaction is exothermic reaction. Forward reaction is exothermic. Now let's change temperature. If the temperature is decreased, okay? If the temperature is decreased, decrease temperature. Decrease in what? In temperature. When we decrease the temperature, that is our disturbance, we decrease the temperature in the system. When you decrease the temperature, generally you favor which reaction? Exothermic, which means we are going to say exothermic reaction is favored. Exothermic reaction is favored because the temperature is decreased generally. Then let's look at forward reaction. Forward reaction is exothermic. Then exothermic reaction is favored by decreasing the temperature. Therefore, ziyafana ezinto zoyi-2. Ithethe ukuthi ke ngoku forward reaction is favored more than reverse. Forward reaction is favored more than reverse. Favored. When forward reaction is favored, the concentration of the products, that is NH3, the ammonia, will increase. The concentration of ammonia will increase because forward reaction is favored. Now let's draw the graphs. The first graph that we have is the graph of the concentration. Then another graph, by definition, chemical equilibrium, another graph is for rate. So we have a graph of a concentration. Then we have a graph of the rate versus time. So we'll start with ixesha, obvious, we'll start with ixesha. Okay, so let's say we have a reactant here to reactant number 1, say equilibrium already, that is hydrogen. Then spin reactant yesibini, that is nitrogen, now equilibrium because flat part the concentration does not change. Then spin ammonia, nayo equilibrium in this stage, that is NH3, zero equilibrium zonke. Now the equilibrium is disturbed by decreasing the temperature. What will happen? As it decreases temperature, ayikho disturbileyo concentration yezinto, like hydrogen is not disturbed, nitrogen is not disturbed, ammonia is not disturbed. Therefore, there will be no sharp increase like this, sharp increase. Into esiyenzile sivele decrease temperature only. So when we decrease the temperature, exothermic is favored, forward reaction is favored. Classic forward reaction is favored, meaning that the concentration of the product increases, which means the product will increase but not sharp increase. What will happen to the reactants? The reactants will decrease, reach equilibrium, reach the new equilibrium. They will decrease and reach the new equilibrium. Then now let's talk about the rate. What will happen to the rate? Let's say we have this line, then we reach the equilibrium. Then we have another line. Let me take this one, this line, and we reach the equilibrium. This one is forward reaction. This one represents a reverse reaction. This one, it's a reverse what reaction? Sorry for that. It's a reverse reaction. This one. Okay, that is the reverse reaction, which is the card for reverse reaction. So this one represents a reverse reaction. This one forward reaction. Then when you decrease the temperature, the rate of reaction decreases because the particles loses the kinetic energy. So when we decrease the temperature, both the rate of forward and reverse reaction decreases. But between the two, which reaction is favored? Forward reaction is favored. Therefore, forward will decrease kancinci, reverse ehle kakhulu, because reverse akekho favored, ehle kakhulu. Forward yena uzo decrease nje kancinci, then reach equilibrium. Forward decrease kancinci, reach equilibrium because favored. Forward mabe ngentla in fact egraphini because favored. Then reverse ke nguye abe ngezantsi because akekho favored. So say reach another equilibrium. Then sigqibile layer. Now let's go to increase in temperature. Let's increase the temperature. Increase the temperature. Okay, let's increase the temperature. Okay, so before that, we said since igraph yethu In fact, since reaction yethu sithi delta H is less than 0, therefore forward reaction is exothermic. When forward reaction is exothermic, obvious reverse reaction, reaction. Since this one is exothermic, reverse reaction is endothermic. Now let's decrease the temperature. Increase now. Increase in temperature. Increase in what? In temperature. Increase in temperature. Generally, when you increase the temperature, endothermic reaction is favored. So when you increase the temperature, endothermic reaction is favored. Endothermic reaction is favored. Okay, now let's check kwezi sentences zethu zokuthi sizibhale lapha. Forward reaction is exothermic, reverse reaction is endothermic, and we increase temperature, we favor endothermic. Therefore, reverse reaction, since we said reverse reaction is endothermic, reverse is favored. Reverse reaction is favored. When reverse reaction is favored, kwenzeka ntoni kwi-concentration ye-ammonia? The concentration of ammonia, now that the reverse reaction is favored, the reverse reaction is favored, the concentration of ammonia decreases to form more particles of nitrogen and hydrogen. So masihambe siyozoba igraph yethu. Since sithetha nge-temperature, this one will decrease and reach new equilibrium. Then the nitrogen increase, reach new equilibrium, and the hydrogen increase and reach new equilibrium. So with temperature, ayikho a sharp increase like with concentration. There is no sharp increase with temperature. Slightly increase, slightly decrease. No sharp decrease. Slightly decrease, slightly increase. Okay, now let's go to a rate. What will happen to the rate? Since we said reverse reaction is favored, in fact, when you increase, the first thing, you increase the temperature, both the rate of forward and reverse reaction increase. Both the rate of forward and reverse reaction increase. But between the two, ikhona ezonyuka kakhulu, ili favored. Reverse reaction is favored. Therefore, reverse reaction will increase more than forward reaction. Reverse reaction will increase more than forward reaction. So uzo increase forward reaction, but akhawuleze ariche ntoni? I-equilibrium. Sijike apha, then this one, the forward reaction ibuye izo reach equilibrium entsha. So there is an increase here in temperature. There is a decrease in what? In temperature. Lingentla, a reaction that was favored. Lingezantsi, a reaction that was not favored. Then specifically apha with temperature. Let's go to pressure. Let's go to the pressure. Then apha with pressure ke ngoku sithi pressure is inversely proportional to the pressure is inversely proportional to the volume. When the volume increases, the pressure decreases. When the volume decreases, the pressure increases. Increase in pressure favors the reaction with less moles. Increase in pressure favors the reaction with less moles. Decrease in pressure favors the reaction with more moles. Decrease in pressure favors the reaction with more moles. So it can land of next balance equation. Here we have 1, Then we have 3, which means we have 4 moles with reactants. 4 moles. Then we have only 2 moles with products. There are less moles, there are more moles of a gas. We must make sure that we are talking about a gas, because if it's not a gas, stating upper with pressure. Now make say increase a pressure. Increase pressure. When you increase pressure, you favor the reaction with less moles. So you favor the reaction with less moles. Increase in pressure favors reaction with less moles, which means in this case forward reaction is favored because moles ezimbalwa forward, that is as a products. So sibhale forward reaction is favored. Forward reaction is favored. When forward reaction is favored, kuzokwenzeka ntoni? Kuzogqibela kunyuka iammonia. Iammonia izonyuka ekugqibeleni, then ezinye zehle. Okay. Now let's draw the graphs. We have a graph yokuqala ngokwe-definition, concentration. Then sibe graph yesibini ngokwe-definition, rate. Because when we define chemical equilibrium, we define nge-concentration, we define nge-rate. Then with concentration sijonga i-particle nganye, that is hydrogen. Then sibe no-nitrogen. Sibe no-nitrogen gas. Then sibe no-ammonia. Sibe ne-ammonia, that is NH3. Then let's look at this one. The disturbance now is an increase in pressure. When you increase in pressure, all of them will drastically increase. Then we check which one is favored. After the increases zizonyuka zonke, then sijonga which one will increase ekugqibeleni. Zinyuke zonke. Then sithi ke ammonia will increase because forward reaction is favored. So ammonia is increase at the reach equilibrium. Increase reach equilibrium. Then ezinye increase, then decrease reach equilibrium again. Decrease ezizoyi-2 reactants reach equilibrium again, because forward reaction is favored. Zona zizawugqibela ngokudecrease, zizonyuka nje ziphinde zidecrease. So we have sharp increase, sharp increase, sharp increase. That is concentration. What the influence of a pressure. Now let's look at this one, that is the rate. With rate we have 2 rates, that is rate of forward reaction and rate of reverse reaction. So forward reaction, then ziyalingana. We have the forward reaction here, then this one is a reverse, that is R for reverse. Then we increase pressure. When you increase pressure, all the rates forward and reverse increase, but one of 2 will increase more than any. So which one will increase? Forward reaction is favored. Therefore, forward reaction will increase more than or reverse. So we reach equilibrium upper because inyuke nje kancinci yona. Then le izobuya ke ngoku phezulu izo reach equilibrium zilingane again. That is an increase in pressure. Now let's go to the decrease in pressure. When you decrease the pressure, you favor the reaction with more moles. Decrease in pressure favor the reaction with more moles, decrease pressure. Decrease in pressure favor the reaction with more moles. Favor reaction with more moles. Zinintsi moles now. Moles zinintsi kwi-reactants, which means the reverse reaction is favored because now more moles will reverse product reactants phaa nee-moles ezininzi, therefore reverse reaction is favored. Reverse reaction is favored more than forward is favored. Reverse reaction is favored. The concentration of ammonia when reverse reaction is favored, it decreases. Okay, now that we decrease the pressure, zonke zizokwehla kakhulu kuqala, then sijonge uba yeyiphi ke ngoku favored. Zonke zizokwehla kakhulu, drastical decrease. Zonke zizokwehla, zonke ziyehla, zonke zehla zonke. Then which reaction is favored? Reverse reaction is favored, which means ammonia yona izokwehla inganyuki because ayikho favored. Therefore i-nitrogen izokwehla izogqiba ithini? Inyuke, reach equilibrium. Then i-hydrogen nayo izokwehla igqiba ithini? Inyuke, reach equilibrium. Let's come to the rate. Which rate is favored? Okokuqala, decrease in what? In temperature. The rate of forward and reverse reaction decreases. But between the two, ikhona ezokwehla kakhulu i-rate. The one that is not favored izokwehla kakhulu. So reverse reaction is favored, which means forward reaction uzokwehla kakhulu yena. Then reverse reaction since favored uzoshiyeka ngentla. Reverse reaction akazukwehla kakhulu. Forward reaction uzokwehla kakhulu because ayikho favored. Then abuye to reach the equilibrium. So learning ngentla, forward reaction ungentla, which means forward reaction was favored. Forward reaction here ungezantsi, which means forward reaction is not favored. Reverse reaction is favored. Now let's look at one example just to analyze the question. More example will come to the next video. Let's check now let's look at this reaction. So we have, in this reaction we have this one, that is N2O4. We have this N2O4, which is the reactants. That is a reactant because E1. Then we have this NO2. Then the reaction is said to be endothermic. So because of that, forward reaction is endothermic because delta H is greater than 0. Now we have only two species here. We have one reactant and one product. So the graphs here no one reactant and one product. So kweli cala igraph yethu ibhalwe ntoni? Concentration. Xa uyi-concentration sijonga one by one. Now sijonge lapha kwesi stage apha. I-1 edisturbiweyo, once inyuke drastically, inyuke kanje, i-disturbed, then sijonge which reaction is favored. Iye inyuka kakhulu le, yeyiphi inyuke kakhulu? Ile product. Ku-addwe more of nitrogen dioxide. Addwe more of nitrogen dioxide. Then ngapha sino N2O4. So apha kwa-addwa another N2. Then icala lizothini ekugqibeleni? Lizokwehla. So ku-addwe more when the time is T3. Kuye kwa-addwa more of NO2 because bona yona inyuke drastically. Then when you add more of, sijonge lapha umzekelo, when you add more of the product, elicala i-disturbed yanyuka kakhulu. Then which reaction is favored more than enye? So elicala engulu lizoba nzima, heavy than lizokwehla lona, then this side is favored because izonyuka. Reverse reaction is favored. Then sijonge kule ndawo reverse reaction is favored because bona lena i-increase i-reactant, increase ekugqibeleni. That is the concentration up factor. The factor is a concentration here. The concentration of this one, that is NO2, is increased. Now let's look at this one. There is no disturbance in the species here. There is no disturbance ku-products nakwi-reactants, which means xa kungekho disturbance kuthethwa ngantoni apha? Nge-temperature. Here it's a what? It's a temperature because there is no sharp decrease or sharp increase. Kwenzeke ntoni ke ngoku apha? Let's look at i-product. I-product yathini? Iya-increase, which means forward reaction is favored. Forward reaction is favored. Forward reaction is what? Is endothermic. Endothermic is favored. Kwenzeke ntoni? Since forward reaction is favored, abe engu-endothermic. U-endothermic uba favored xa usenzani? When you increase. When you increase what? Temperature. Endothermic is favored. When you increase temperature, endothermic is favored. So endothermic is favored because it increases temperature. Forward reaction is favored because sibona le increase le sithini i-decrease. So ihamba kanjalo. Then we can answer the questions, but we will answer the questions on the following video. Thank you for your time. Please subscribe to this video. Thank you.